All right, chapter 4 review. We're looking at problems 6, 7, and 8 in this video. And here we go. So the first one says, solve the following equation for the indicated variable. We have a formula, capital A equals 4/3 times little a times x to the third power. And we want to solve it for a. So first thing we're going to do here is I want to identify that my a is what I need to get here. There's only one of them. There isn't any on either other side. So I'm going to take it here. I'm going to rewrite this so it looks a little more familiar, a little bit easier maybe for some people. I'm going to say capital A equals, I'm going to say 4 times a times x to the third over 3. Now 4/3 is the same thing as multiplying the ax cubed by 4 and then dividing it all by 3. That's why I wrote it this way. You know, you don't have to do it this way, but I just think this will help some people. First thing we're going to do here, let's get rid of the 3 because we've got things that are being multiplied and things that are being divided. We're going to take it here. I'm going to multiply each side times a 3. And now we're left with 3 times capital A equals 4 times a times x to the third. Now multiplication is commutative, right? So since its order isn't going to matter, this is the same thing as just saying 4 times x to the third times a equals 3 times capital A. So I want you to think about it like that. So I've got this product here that I'm multiplying times a. If I want to get a by itself, I can go ahead and just divide by that product. You don't even have to rearrange the order like I just did. I just hope that that will make it easier for some people to see. So you're going to have 4x to the third in our denominator. So right now it's 3a, or 3 times capital A, over 4 times x to the third power, and that equals a. Now other variations of this answer, you may see something like this. You may see 3/4 times a over x to the third power. So the numbers are broken off. That's an a there. That equals a. So you could have either way there. Pretty much though, you'll see that this and this are about the exact same thing. All right, let's look now at 7 and 8. It says, solve the following systems of equations algebraically. So we're looking at 7. Right now we've got x squared plus y squared equals 25, and we've got y squared equals x plus 5. So we've got a circle, and then what looks like it's going to be a square root function and its opposite. But if you don't see that, don't worry about it. We're just going to take it here, and we're going to solve it. If you look here, we've got a y squared, and in the other equation we also have a y squared. If this y squared equals x plus 5, we can take x plus 5 and substitute it in for this y squared. So we're going to say x squared plus the quantity of x plus 5 equals 25. And now this looks way more familiar to us. We're going to subtract 25 from each side. So x squared plus x minus 20 equals 0. This is just a quadratic and it should factor. So we're going to have x plus 5 times x minus 4. And then we'll take it here, we'll get x plus 5 equals 0. X minus 4 equals 0. So x equals negative 5, or x equals 4. Now remember, this is a system of equations. So we're going to take these values here, and we need to know the rest of the points. So we're going to take -5 and plug it in for x here in either one of the equations. It's up to you which one you do. I'm going to plug it into the top one. So I'm going to say -5 squared plus y squared equals 25. -5 squared is 25 plus y squared equals 25. So we know here when we subtract 25 from each side that y squared equals 0. So that y is going to have to equal 0. So we're looking at the point -5, 0. And when we plug in 4, you can plug it into the same one, or you can plug it into the second equation there. Let's look at that. Let's do y squared equals 4 plus 5. So we get y squared equals 9. And when we take the square root of each side there, we know that we're going to end up with two answers. We're going to get 3 or -3. So that's weird. When we plug in 4, we get two answers. So that means we're going to end up with two more solutions. We're going to have the point 4, 3, and we're going to have the point 4, -3. So this one actually has 3 solutions. If you plug those all back in, they all work. If you graph each of the systems there, you will see that it has 3 intersections as well. This one would have kind of a look like this. You've got your circle, and then I believe we've got a square root function that goes out this way, and then a negative square root function that goes out that way. And that's where you get 1, 2, 3 different solutions. All right, number 8. Please check your paper here, because this one was x plus y equals 0. It was originally minus on some versions of the review, and it was supposed to be changed. So if you didn't get the message to change it, you may want to change it now. So I'm going to take this and I'm going to say here that y is going to equal -x, because if I subtract x from each side, I have a y right here and a -x on the other side. I'm going to plug that -x in for y. I've got -x equals the quantity of x minus 3 squared minus 5. Now I'm going to just solve this for x. I'm going to FOIL this side out. So I have x squared minus 6x plus 9 minus 5 equals -x. I'm going to combine my like terms and add my x to each side here all in one step to save some time. So we have 0 equals x squared minus 5x plus 4. That should factor into x minus 4 and x minus 1. So in the end, we get x minus 4 equals 0 and x minus 1 equals 0. So x equals 4 or x equals 1. Now we take those and we plug them in to get our other values. So we have 4 plus y equals 0, which means that y would have to equal -4. So that's one solution for -4. And then we plug in 1 there. We've got 1 plus y equals 0. Subtract our 1 from each side. We get y equals -1. So our other answer would be 1, -1. Now again, we could take this, we could graph each of these to make sure that this will work. But for time's sake, I'm going to go ahead and tell you that it does. Okay, because this is a line and this is a parabola. The most they can intersect in is 2 points. All right, so that's problem 6, 7, and 8 from the Chapter 4 review. Hopefully this helped you out. If you have questions, please make sure you ask your teacher.